All right, well, thanks for coming today, everybody. Really appreciate you taking the time to be here this morning with us. This is CMP331, save up to 90% and run production workloads on Spot instances. My name is Chad Schmutzer. I am a principal developer advocate with the EC2 Spot team. So what is a principal developer advocate? That means I get to help customers adopt Spot instances within their environments, and it allows them to do a couple of things, right? It helps them save at scale and to run workloads at scale that they may have never run at before. And it's a really satisfying job. So it means I get to help customers save at levels that they typically don't get to look at. So up to 90% off of your bill is a pretty significant thing, and it's a lot of fun to help customers do that. I am joined today by two customers who have used Spot to do a couple of things, to run workloads at scale, as well as to save at scale. And so I would like to introduce to you John Weber from Adobe and Devang Sampit from Hulu. So I will turn it over to John to say hello.
Hey, I'm John Weber. I'm a senior manager in the site reliability engineering organization of Adobe. I run several products and platforms in the creative media or digital media side of the house of Adobe.
Hey everyone, I'm Devang from Hulu. I'm the manager for the production engineering team. I've been at Hulu for about 6 years, and my team does a few different platforms, including a simulation platform, a traffic engineering platform, and an observability platform.
Thanks, Devang. And John? So, all right, so let's get into this a little bit. As I said, I'm a developer advocate for Spot, and I get to help customers save at scale, understand what Spot is. So what we're going to do today is talk, here's our agenda. We'll talk about what is Spot. If you haven't used Spot before, you'll get an overview of what Spot is, understand the key concepts and the best practices to use Spot successfully in your environment. We'll talk about what's new with Spot. What have we been working on over the last couple of years, this last year most importantly, and what are we working on to help you adopt Spot in your environment in a quicker and easier fashion. And then I'll turn it over to Hulu, to Devang, to talk about how they use Spot at scale for some really neat workloads in their environment. And then John will tell us how Spot is being adopted at scale in an enterprise environment at Adobe. All right, so in order to get a baseline around Spot, let's take it all the way back to 2006, right? So in 2006, we introduced an instance called the M1 Small. Has anybody here in the room used an M1 Small? Have you been on AWS long enough to use an M1 Small? Okay, so some folks that haven't been here since 2006. But basically what we did was we launched an instance, and we started to say, okay, here's an instance that customers can use. And at that point, we had spare capacity, right? So we had spare capacity in our environment, and we said, we have to be ahead of the curve. We have to have enough capacity to allow customers to spin up and spin down resources whenever they need them. It's a little bit hard to predict how much capacity we'll need on our end for our customers. And so this is something that we've been trying to stay ahead of the curve, make sure that we always have enough spare capacity for our customers when they need it. But really at that point, we had to start to think about how do we make effective use of all of our capacity. And so, right, a couple years later, 2008, we continued to grow. So we launched the M1 Large, the M1 Extra Large. In 2008, we also launched the C1 Medium, the C1 Large. The next year, 2009, we launched the M2 series, basically saying customers are telling us, hey, we like these compute instances. We would like some instances that are also more tuned to what we need for our workloads. We need more memory. We need them to be compute optimized. We need this and that. And so again, adding more capacity to our data centers to allow customers to run at scale in the cloud. And we have to stay elastic to allow our customers to be able to do that. And then as you can see, we added even more instance types over time. So at this point, and I can't even keep track, I believe we're over 270 plus different instance types that you can choose from in your environment. But we continue to grow and grow. As we continue to grow and grow and to rack and stack more physical hardware in our data centers to allow customers the flexibility to run the workloads they need to, we grew and we have more and more spare capacity in our data centers as a result of this rapid growth. So at that point, around 2009, we said, hey, we have an opportunity to allow customers to tap into all of this spare capacity. And at that point, we launched a product called EC2 Spot. And let's get into what this is. You're probably familiar with these. If not, I'll do another baseline. There are 3 different ways to get access to our compute capacity from a purchasing perspective. The first you see on your left is the on-demand, right? Sort of the tried and true utility-based compute model where you're paying for resources on demand, just like the electricity. Turn the light on, you pay for it, you shut it off, you stop paying for it by the second. Same thing applies for on-demand utility-based pricing for our compute resources. So all those 270 plus instance types, you can turn them on, you can shut them off whenever you need to. This is on-demand pricing. It's great for spiky workloads or as you're defining your workload needs. For those of you that sort of understand what your workload requirements are going to be over a given period of time, we have the opportunity for you to lock in significant savings off of the on-demand price through savings plans or RIs. This is where you're saying for a committed spend over a 1-year or a 3-year period of time, you can use our compute capacity and achieve significant discount off of that price for that committed run, committed usage on our platform. All right, so those are the sort of the tried and true different ways to purchase compute. The third model, which is what we're focusing on today, is access to all of our spare capacity through what we call EC2 Spot Instances. EC2 Spot Instances are basically allowing you to pay and by the second with savings up to 90% off of the on-demand price to get access to our spare capacity. So spot instances are great for fault-tolerant workloads, flexible workloads, stateless workloads, lots of different use cases, and Hulu and Adobe will talk about some of these use cases here. But basically, this is allowing you to tap into our spare capacity that we just talked about here in the previous slides. So one of the things that customers ask me continuously is, well, how much spare capacity do you have? I can't tell you that number exactly, right? We don't disclose exact capacity information. However, I can tell you we have customers running 1 million plus virtual CPU workloads on a regular basis just on our spare capacity, typically even in a single region. So one of these use cases here is Western Digital, right? Western Digital, right? Very large hard drive manufacturer. One of the things they need to do is to simulate, hard drives so that they can understand what is the failure rate under different conditions. And so they need to run these simulations over and over and over. They were running these simulations in their data centers. These simulations typically were taking 20 days to run the complete gamut of this simulation. They said, well, let's tap into the cloud. We want to do it in a cost-effective way. And so they ended up using Spot instances. And so they were actually able to run this simulation that they needed to and reduce the runtime from 20 days to 8 hours by running over 1 million virtual CPUs just on our spare capacity in a single region. And you can see here, we've got a graph of them. They were very flexible. They ran over multiple instance types, sizes, families. But you can see they did this in 8 hours. They spun it all up. They ran their simulations. They shut everything off, and they moved on, only paying for what they used as they went. So a really awesome use case for customers tapping into our spare capacity. So again, I can't give you the exact number, but some other hints, right? So a quote I like to talk about is basically, on average, every week, AWS customers are using more compute capacity on EC2 Spot instances than customers were running across all of Amazon EC2 in 2014, right? So just on Spot, we're running more than all of EC2 back in 2014. So you can see the tremendous growth and the tremendous access you have to our spare capacity. All right, so what I want to talk about here is sort of what are the fundamentals of Spot, right? So I've told you it's our spare capacity. It's cheap. It's up to 90% off of the on-demand price. So what do you need to know about it in order to be successful? So let's kind of drill into each of these categories here. First of all, Spot is our spare capacity. There's nothing different about it. It's the same infrastructure that is powering the on-demand instances. It's not like it's a different set of hardware or it's something else. It's literally the unused on-demand capacity that we have running in our data centers. We've already purchased it. We've already racked it. We don't want it to sit idle. If somebody else is not using it in on-demand, we want Spot customers to get access to it. And that's what it is. So it's the same infrastructure. Everything is the same about it. Second is that Spot pricing is very smooth. It's typically 70 to 90% off of the on-demand price. We publish the Spot pricing history. You can look it up. You can say, what were the spot prices over the last 3 months if you want to look at it. But we typically don't recommend you focus on that. Just understand when you use Spot, you will be paying as much as we can, we can give you off of the on-demand price to allow you to achieve your savings. We can change spot pricing if we need to, gradually, to adjust for trends in supply and demand. So as different pools of capacity have different trends in how much is being utilized day to day, we can change spot pricing if we need to, but it's relatively smooth, and I'll show you a graph of what this looks like here in a moment. But we wanted to make access to our spare capacity as easy as possible, and as a result, we've tried to make spot pricing as smooth as possible so that you can sort of understand and sort of predict what your costs are going to be when you do tap into spot instances. So Spot can be interrupted, right? So what does this mean? In exchange for the steep discounts you get with Spot instances, we have the option of giving you a 2-minute notice that a Spot instance is going to be interrupted, and then we would take back that instance from you, right? So what does this mean? We can give you an interruption notice in 2 ways, on the EC2 instance metadata as well as a CloudWatch event. So we give you a 2-minute notice that this instance is going to be interrupted. You can capture that notice, you can take action on it, you can checkpoint, you can drain connections, you can drain containers, you can disconnect from a load balancer, resubmit a job, whatever it is you need to do. But you do have access to that 2-minute warning when we do need to interrupt a Spot instance. So this is the primary difference between an on-demand instance and a Spot instance, is that we can interrupt you with that 2-minute notice. I'll show you another slide what this means here as well for you. But just understand that this is the fundamental difference between an on-demand instance and a Spot instance. When it comes to Spot, the fundamental best practice is to be flexible, right? And what do I mean by that? In order to achieve the most significant cost savings and to get access to our spare capacity, you want to be flexible across all of the different generations, the different sizes, the different instance types, and availability zones, right? Because our capacity is structured such that we have spare capacity in these different pools, and it's going to change day to day depending on the elasticity of the cloud. One customer may be using a bunch of this pool, then one day, the next day another customer uses this. In order to tap into the spare capacity, you want to be flexible and find the pockets of spare capacity that we have. We always have spare capacity somewhere. It's just a matter of being able to find it and spin it up and use it in your environment. And we have tools that will help you achieve this. So, pricing. Here's an example graph. This is just a screenshot from the AWS Spot console where I looked at the R4 8 extra large over the last 3 months across 3 availability zones. Which region is this? US 2A, so in Ohio. So you can see here, we've got 3 different lines. You can see that blue line in US East 2B, had a little bit of fluctuation in price there over a period of time, but typically spot pricing is relatively flat. When you spin up a spot instance, you just pay whatever the current spot price is. You don't have to worry. You're always going to get the lowest price available to you for that particular pool of capacity. So you can see, this isn't the same for every instance type in every availability zone in every region, but typically spot pricing is relatively flat, and it isn't something you need to continuously worry about. So I'm just showing you this slide to say, we will give you the lowest possible price that we can when you're using the spot instances in your environment. Okay, so I talked about interruptions. Interruptions are a part of Spot, right? So it's something that you should get comfortable with. It's something that you should architect for, and something that you should be, your application is tuned to and able to handle in your environment. But at the end of the day, we're not in the business of running around interrupting everybody as much as we can. We want to leave you alone. If we can let you run your spot instances for as long as you can, more power to you, right? We're not trying to interrupt you. If you have a spot instance running and we don't need that capacity back, you can have it for as long as you need it until we need it back. So what does this mean? Less than 5% of all running spot instances were interrupted by us over the last 3 months, right? So we're not in the business of running around interrupting everybody all of the time. So what this computes to in your environment is you do want to make sure that your applications are interruption tolerant and able to handle the interruption. So that means Spot is the best fit for things like stateless workloads, fault tolerant workloads, stateless workloads, flexible workloads. However, if you're in a position where you're already maybe able to use an auto-scaling group, an EC2 auto-scaling group, Spot is really no different than scaling up and scaling down an EC2 auto-scaling group. So keep that in mind. If you can use auto-scaling, EC2 auto-scaling, you can probably use Spot instances in your environment. So it's a nice way I can tie that together for most customers to think about. Again, that 5% of interruption is across all Spot instances running across all regions. That number will fluctuate depending on the demand for a particular instance type or how much capacity depth we have or how much demand there is for that particular day. However, in general, again, interruptions tend to remain relatively low. So what do we need to think about here? We need to think about flexibility within your environment. And the reason for this is because each instance family, right? So let's take the C4s for example. In each instance size, in each availability zone, in every region, is a separate physical pool of capacity, which translates into a separate Spot pool. So this means each of these pools is going to have slightly different pricing. Again, we're going to keep it as low as we possibly can for you, but it's important for you to think about how many different pools can I use in my environment. Sometimes I talk to customers and they're like, hey Chad, we only use R5 larges. Well, why? Well, because we love them, right? They're great. I say, well, have you considered using the M5 larges? They're very similar. Well, no, I didn't think about that. Well, what about the C5s? What about the M5As? What about the R5As or R5Ns? There's lots of different options for you. And then the light bulb starts to go off. The more flexible you are across these, the more access you have to our spare capacity, and the cheaper your overall cost will be in your compute environment because you can find the spare capacity, you can find the lowest prices within Spot. So next fundamental question customers say is, well, this sounds great, Chad. You've told me about this spare capacity. You told me about the low prices. Where can I really use it in my environment? So these are sort of the 5 areas where we sort of zoom in with customers and say, well, do you have any big data? Are you running any workloads, ETL jobs? Are you running Spark? Are you running Amazon EMR, MapReduce jobs, Hadoop jobs, Spark jobs? If so, big data is a great use case for Spot, right? You can get access to a lot of spare capacity, a lot of compute, a lot of memory for cheap, spin it up, spin it down, decouple your compute and your storage, and you're on your way. Spot's a great fit. CI/CD, continuous integration and delivery. You probably have some environment, a Jenkins environment somewhere where you're deploying jobs, you're doing build jobs over and over. These are typically ephemeral, right? You launch a job, you build a job, you shut the instance off, you start a new job. If that job happens to get interrupted, you can restart it. Very good fit for Spot in the CI/CD world. We have a plugin for Jenkins, a plugin for Bamboo. Web services, the tried and true EC2 auto-scaling group behind a load balancer. If you can do this already today, you can probably lock in some Spot there in your environment. You can probably scale up and scale down with Spot just as you can with an on-demand instance in your environment. So think about how you can adapt some Spot instances to save in your environment for web services. High performance computing, right? So workloads that are distributed, loosely coupled, need a lot of compute capacity, but probably run for a set amount of time. You shut them off when you're finished. Think about Spot in these environments as well. And then finally, containers, right? Containers are very hot right now. They're trendy. Everybody's using Kubernetes. Customers are using ECS. Think about using Spot in your containerized platforms because you already have the ephemeral nature of containers. You're already working in a stateless environment. Typically, Spot is a fantastic fit for your containerized platforms as well. So think about how you can use Spot in these environments. These are great great workloads to get started with. I have an entire GitHub repo with examples of CloudFormation templates and demos on how to use this, workshops in these individual environments. So if you're interested in any of this, see me after. We can talk about these. I can give you examples on how to get started and talk about how other customers are doing this in their environment. So what's new for Spot in 2019? All right, we've been working very hard to make Spot easy to use in your environments. Some things that we've done here. We've worked very hard to integrate Spot into other platforms, not only other AWS platforms, but also third-party platforms. So you can see on this screen, we have a whole set of other AWS services where you can use Spot natively directly within the service. We just announced yesterday enhanced functionality with ECS with Spot, with compute providers. Elastic Beanstalk the last couple weeks just announced integration with Spot. So we've been working very hard to make Spot a native resource and available, making it very available within other AWS services as well as third-party services. EC2 Autoscaling. We want to make Spot as easy to use in your environment, and we've done this by integrating Spot more tightly into EC2 Autoscaling. So we've done a couple of things. We've allowed customers to provide multiple instance types in an EC2 Autoscaling group. We've also provided a new allocation strategy called Capacity Optimized that tells the Autoscaling group to go find the most available Spot instances within the Autoscaling group. So there's a whole bunch of functionality directly built into EC2 Autoscaling groups that help you optimize for both cost and scale in a single Autoscaling group. You can mix and match Spot and on-demand within a single Autoscaling group, and you can tell it to go figure out how to achieve the capacity that you need. So it helps you reduce cost, optimize performance, and eliminate operational overhead. So what does this look like from a practical perspective? Let's say I have an EC2 Autoscaling group, and I've mixed M4 large with Spot, M5 large with Spot, and C4 large with on-demand. I can put all of these in a single Autoscaling group and tell the Autoscaling group to go figure this out, fire off the capacity, maintain my on-demand capacity, maintain my Spot capacity, and figure it out for me. Well, as I said, Spot capacity can come and go. What happens if one of these capacity pools is constrained and we need to interrupt one of these instances? Well, the Autoscaling group will say, okay, don't worry, I know I can find another Spot instance in another pool of capacity. I'll launch another one over there, and when the other pool becomes unconstrained, I will rebalance for you automatically and help you maintain your capacity. So the Autoscaling group is very powerful in terms of figuring all of this out. As long as you're flexible and feed the Autoscaling group with a list of instance types it can use, and you tell it what you need, the Autoscaling group is very functional and capable of maintaining all of this for you. As I said, we also have done some additional integrations with other services. ECS just announced automated draining with Spot instances. So your containers can automatically be drained upon interruption notices. That interruption handler is built into the ECS agent. We also announced yesterday additional functionality of fully managing your Spot instances within Spot clusters within ECS. So go check it out. There's a link there. You can check that out. There's a direct link to the GitHub repo as well where that code has been published in the ECS agent. EKS, we built a node termination handler. For those of you that are running Kubernetes, we published recently an AWS node termination handler that supports automated draining for your Spot instances within your Kubernetes clusters or your EKS clusters. So check it out, right? It's in GitHub, it's public domain. Check this out, it's been very popular, a lot of downloads so far, but we're trying our best to make Spot super easy to use in your containerized environments. AWS batch processing at scale. You can use Spot natively. You can tell it to go figure out through allocation strategies which strategies to use, capacity optimized versus best fit progressive. Finally, another example of a customer, Nextroll. They just published a blog post in 2019 using batch and Spot together. They've been able to save save $4 million just by using Spot and batch together. So a very powerful statement from a customer who said, we've been able to save at scale through the integration of batch and Spot, two services that we use heavily. So just sort of wrap it up. We're working very hard to make Spot easy to use in other AWS services as well as third-party services. If you have a tool or an API or a product that you're using in your environment that you say, hey, I wish Spot was there, let me know. Give me a shout on Twitter, shoot me an email. Happy to take that feedback from you, and we'll work as hard as we can to get Spot integrated. So at this point, I'm going to turn it over to Devang to talk about Spot in production at Hulu.
Thanks, Chad. Sure. Hey everyone, I'm Devang from the production engineering team at Hulu, and today I'm going to talk to you about a system we built that runs 10 million containers on top of EC2 Spot instances. But first, a bit of background on that'll hopefully give context for why we needed to do this. First, what exactly is Hulu? For those of you that aren't familiar, Hulu is an online streaming platform that offers live TV and subscription on-demand content. Our customers can watch on mobile, web, and in the living room. And as of May of this year, we had a bit over 28 million subscribers. We also first started using AWS when we launched our live TV offering back in May of 2017. So it's been about 2 years for us on this journey. At Hulu, most of our services focus around 2 different types of workloads that correlate to our 2 different product types, VOD or video on demand and live. For VOD workloads, as long as playback starts within a few seconds, we don't really care about latency because once you're in the stream, not too much is changing as long as there's minimal buffering. The second thing is that we have a much larger content library for on-demand, and so caching requires us to think about how to keep this long tail of content always available. And the third thing is that our load profile follows predictable peaks and troughs. Most people get home from work on a Monday at 5 o'clock, turn on the TV, they're watching, they go to bed at 9. So our load profile and our RPS graphs can be measured in hours, and everything's good and nice and perfect because it all looks like a beautiful sine wave. Live TV is a totally different beast. Live is extremely latency sensitive. Like imagine if you're watching a sports game and you hear your neighbors cheering and then 30 seconds later you see the action on your screen yourself. The other challenge is that for the same live event, because there's different local affiliates in America, we could actually have 50 to 100 different streams for that same event on one channel. And this also means that we really have to take into account the geographic distribution of our viewers, because for example, if it's a Laker game, there's probably going to be more people in Los Angeles watching than in Montana. And the load profile for live is extremely spiky in that if it's a big event, like let's say it's a Super Bowl and there's a touchdown, we could see our viewership double in a matter of seconds. So we don't even have like 2 minutes to react to things sometimes. And so for us, the unpredictability and spiky nature of live TV provides the biggest challenges from a scaling perspective. So let's talk a bit more about the exact problem we were trying to solve when we built this system. So one day, our business came to us and they said, hey, we know that live TV is spiky. Can you build a system to simulate a spike of X million viewers with a click of a button? Essentially, they asked us to give them a load testing framework so we could simulate things like the Super Bowl happening every week instead of waiting once per year. As engineers, we took a step back and we realized that really what we should be building is a system that allows us to deploy, bootstrap, and execute X million instances of a code artifact within a certain amount of time, which is more akin to a batch job processing system. And the reason I bring this up is because even though we're using this system specifically for doing load testing, as long as you follow the same assumptions and design principles that we have, there's no reason this system can't be reused for other types of workloads. And so hopefully some of the lessons that we learned are still useful to you, even if you're not trying to use it for load testing specifically. We had 4 main assumptions when we were designing this. The first is that we assumed developers wanted to deploy an artifact written in arbitrary technology. The reason for this is that at Hulu, we have a polyglot environment. We believe in letting developers choose the best technology for the job. So we have Python, Ruby, Go, Java, you name it, all running in production. And we didn't really want to be in the business of having to write all these language-specific libraries and maintaining them. So instead, we said, hey, can we just give everyone a single interface? And we decided that the minimum input to our system would just be a Docker file. Whatever workload you wanted to do, you just package in a Docker file and we'll run the Docker file. And that helps us get rid of any language that helps us to be language agnostic. The second assumption that we had is that each instance is stateless after it's provisioned. The reason for this is it just reduces the complexity of the overall system. If we had to support having stateful restarts, given that we only sometimes get 2 minutes to handle the termination of a spot instance, that would sort of be extremely complicated for us. And so just making that a requirement made it a lot easier. The third is that we needed to be cost efficient. Every time we were running one of these load tests, which was at least every week or two, we were pretty much buying a new car. And by moving to Spot, the advantage for us was that instead of buying a Model S every time, we were now buying a Honda Civic. And the final requirement that we had is that we needed to be able to stop the workload within seconds. The reason for this is we're doing all of our testing against our production systems. And so we never want to negatively impact our customers. But if we are doing load testing in production, there's a good chance we could do that. And so we we needed to build in multiple fail-safes that allowed us to quickly stop a load test if we saw any issues. So let's talk a bit more about the design. When we first built the system, we launched it with, this was part of our testing for our live TV launch 2 years ago. So it's actually been through 3 major iterations since then. Because we also were so used to building things for the data center, everything in AWS was new to us. And so we learned a lot of different good practices in the exercise of getting to where we are today. So the first design that we had is the developer would say they want to run a load test or something. They would provide us a Docker file for it. And we would take that Docker file, build it if needed, and store it on Amazon ECR, their Elastic Container Registry service. And then we would spin up a Spot fleet, and then each instance would pull the image off the ECR registry, and then we had a simple bash loop that just said, for xin 100, Docker run this container. That worked fine up until about 75K vCPUs, or around a bit over 100K containers. The challenge there was that we were also using ECR for our production workloads to do deployments and storing our normal application images there. And so we started hitting into a lot of rate limits and account limits. And we didn't really want to ever be in a scenario where deployments are now stopped because we're running a load test. And so the first iteration that we did to sort of break through our limitation was that we decided to use a factory pattern using Amazon EBS Elastic Block Storage devices. So what we do now is, instead of having each instance directly pull the image from ECR, we actually cache the image onto an EBS volume. So if you follow along on the diagram on the right, now after the image is built, we spin up a single EC2 instance with an EBS volume mounted at varlib Docker. That single instance only pulls it off ECR, and then we snapshot that EBS volume, and then when we spin up the Spot fleet for the actual load test, we just mount that snapshot. And so that effectively just works as an on-disk cache, and we never have to go to ECR again. And that worked pretty good and got us up to 200K vCPUs, around 800K containers. The challenge there was that around that time, our business really started exploding, and our business came to us and said, hey, we actually need you to go to like 10 million in a few months. Good luck. So to do that, that's where we started getting a bit nervous, and we really had to just start thinking, how can we push every single benchmark we have, find every possible issue, and then triage those and just work through it. And so for us, we found 3 main issues that we had to overcome. The first was we kept running out of IPs. The second is whenever we requested a Spot fleet, sometimes we would be unable to find sufficient hardware. And the third is that we would hit different account limits. So how exactly did we work through these? Well, for the first one, for running out of IPs, this was partly our own fault. What had happened is, since we were used to working in the data center, we took our data center networking design and tried to just augment AWS on top of it. So what that meant is we were using 2 regions, US East 1 and US West 2, and we were requesting 1 Spot fleet in each region. And for context, each region had 1 VPC with 3 AZs, and each AZ had a /20. That part's fine. The part that was a challenge was that our entire IP space was a /8 that we shared with our production services and with our data center. So that meant that we would continuously be fighting for IP space with the rest of our services, and finding a large contiguous subnet, which reduced the complexity of building the system, was super challenging. And so our solution there was just get our own IP space. Original intent for sharing the IP space was because we also do our load testing against our internal endpoints. And so what we have now is we actually have 2 systems, one purely for internal testing on the internal space, which is a much smaller demand in terms of the maximum size of number of containers. And then we have one for our public production testing, which is on its own dedicated IP space. The second problem that we had is that we were unable to find sufficient hardware. And this was partly due to our own fault again with step 1, where we kept running out of IPs because we were trying to reuse this space. Because we had such a limited number of IPs, we were using very few instance types. We were trying to be as beefy as possible. And in general, when you're using EC2 Spot, it's a good idea to use as many different types of instance types as possible, because that just means it's more available capacity. And so when we solved the first issue, that solved it and got us a maybe like 20% bump. But what really was a game changer for us was when EC2 came out with the new capacity optimized allocation strategy. With that strategy, essentially what you're doing now is saying, instead of give me this capacity at the lowest possible price, you're saying, give me the capacity I want and prioritize the delivery of the capacity, but it may come at a slight price premium. And for us, that premium was totally worth it because it improved the overall reliability of our system. Before that, before we switched that allocation strategy, every maybe 1 in 10 runs, we'd have developers complain that we were encountering this issue, we weren't able to find capacity. And after we've switched to capacity optimized, I don't think we've even had a single instance of that issue anymore. It also had an unintended benefit where the complexity of our spot fleet logic actually got simpler. Because previously, we were using target capacity combined with weighted capacity as sort of a scaling factor to hack around it, because we were requesting such a large amount of capacity. And at the time, target capacity was capped at 3,000 units. I think now it's maybe 5,000. But again, we're trying to get over 1 million vCPUs, millions of containers. And so being able to switch to capacity optimized was really helpful to us. I think we were one of the first alpha or beta customers, and we started having some issues with fractional weights that turned out to be a bug. But the AWS folks were totally on it and fixed it for us right away. And so even though it was a beta product, they treated it as if it was actually GA. The final issue that we had was account limits. And this was because when we moved to AWS, we just put everything into a single account that was totally flat. Everything was fully connected. And because of this, it meant that every time we asked for an account limit to be bumped, someone else who was in the process of migrating to AWS would end up using that new capacity or instance type or whatever for their own use case. So figuring all this out actually took us a good chunk of this year. But having known all of this stuff in retrospect, we were able to run our final benchmark and give our business what they asked for, which was be able to run 0 to 10 million containers in 30 minutes. We did that using 1.6 million vCPUs across 2 regions and 87,000 instances. So this was really a big milestone for us, because there's technically a V0 that I didn't mention, which was you would page me, and if you wanted to do a load test, I would come to whatever conference room you're in and use my laptop to run the load test. From there, we decided, hey, there's this cool thing called AWS. We'll go there. We did V1. As we learned more about AWS, our system got more and more reliable. And now the system is pretty much just there. We barely do any maintenance on it, and it just works. And we have teams using the Docker file interface to run other workloads on top of it as well. So that's what we got to this year. Our goal is to keep pushing this number ever higher. So I hope to see you guys next year to tell you about us getting to 100 million containers or something. But until then, I'll leave it to John from Adobe to share his experiences.
Thanks, David.
Thanks.
All right, so I'm the only thing preventing you from getting another cup of coffee, so I'll try to keep this brief and get to the point. My name's John. I've been with Adobe for 9 years. I'm a senior manager in SRE organization, and I didn't want to really tell you about any of the cool features, that just came out with Spot, and I wanted to describe kind of how to use it in a large enterprise organization like Adobe in a safe and effective manner. So I like to call us, and I'm very proud of this, that we're a tech dinosaur. We've been around since the early 1980s, and we revolutionized the desktop publishing industry with PostScript, and that was subsequently licensed to Apple, and the rest is kind of history. In many ways, people still look at us as a box software company, right? When you hear Adobe, you think of Photoshop, you think of Acrobat, you think of After Effects, Dreamweaver. So in the mid-2000s, we began to release web-based services. A lot of these were initially done via acquisitions. A couple that I personally worked on, Adobe Connect, which is a collaboration service, was from Macromedia called Macromedia Breeze. There was a primitive form of Google Docs called Buzzword that turned into Acrobat.com. And then in 2012, we do something kind of crazy. We completely ditched the perpetual license model, and we move all in on subscription. And so today, generally speaking, the only way to really use an Adobe product is through one of our subscription offerings. So as part of enhancing that desktop experience, Adobe really wanted to bundle web-based services to kind of make the desktop experience better. Okay, so a couple of these that you probably would think of when you deal with collaboration and assets. So synchronization, right, kind of like Dropbox style functionality where you take an asset and it's available anywhere. Collaboration, I have a Photoshop file, I want to share it with you and collaborate on it. Machine learning, those are just a couple of examples. And so, again, going back to kind of this metamorphosis from a box software company, we took some of these same developers and said, hey, why don't you go write a bunch of web-based services and not only do that, but do it in an ephemeral environment like AWS. Okay, so I'm an SRE and I'm thinking, wow, that's going to be really interesting. So out with the old, in with the new. So going from data centers to cloud, right? Stateful applications to stateless, monoliths to microservices, perpetual to volatile, right? Surely our developers are all set up for success here. So let me talk to you a little bit about kind of what Adobe's like, what our culture's like. And it's generally the developer culture is one of autonomy and freedom, right? And if you think about it, it kind of makes sense, right? We enable creatives to do really awesome things. Okay, and they take a blank canvas and tell a really compelling story. And again, letting developers be creative is really scary for me as an SRE, okay? So I also ran what was kind of considered the core SRE team on the creative side of the business. I ran a lot of products and services in the digital media umbrella. Let me just say that our design patterns were inconsistently inconsistent, okay? We would have different infrastructure implementations, we'd have AWS account sprawl, we'd have really inefficient use of public cloud resources. We'd have really hard governance challenges, okay? Not only that, but Adobe's really decentralized organizationally, so that really compounds the consistency challenge that I just highlighted. So how do we take a company with this type of culture and this type of landscape and enable developers to do a couple different things in public cloud? One, ensure availability, and two, ensure cost reduction, right? As more and more we were creating services in AWS, our bill was increasing, right? And so we looked at AWS Spot. Great, this sounds great. Let's save 90% on our bill. So we took a look at it, okay? And as Chad said, all right, Spot really works in, if you follow these guidelines, okay? So great, of course, anything that's stateless, okay? Everything auto-scales, right? Surely, everybody in here, every workload that we all run surely is auto-scales, okay? Low priority work, right? Low cost acceleration, okay? And then we looked at our design patterns and those didn't necessarily match, right? So we went, man, this is gonna be really hard, okay? So, and our main challenge was around state, okay? So how do we deal with that? Is it perpetual instances? Well, with reclamation being a requirement for Spot, well, that kind of kills that. Do we hibernate? Is this like your laptop? You just close it and kind of put it to the side? Do you store it off instance? So EFS, S3, RDS, something like that. So what did we do at Adobe? So, being there 9 years, knowing the environment, knowing the technology landscape, I really think that in order to use something like Spot effectively and safely, you really have to implement some type of guardrails, okay? And the way we did that at Adobe is we created an operations platform called Ethos, okay? So it's platform agnostic, so we run it in AWS. We also run it in our data centers that we still have, okay? And, taking away the AWS console from some developers, it's like they really like it. I also think as an SRE, the AWS console generally can be very dangerous, right? You can do some really bad things in there if you, aren't well caffeinated. So, if we're gonna go ahead and abstract the platform and provide things, provide compute via platform, how are we gonna do that, right? What are we gonna give the developers? And it's a give and take type of relationship is how I would put it. So let me give you kind of the core tenets of this platform. It's the 3 C's. So the first one is containerization, and we chose the ever popular technology called Docker. So pretty much we told service teams, you must containerize, okay? The second one is CI/CD. So again, moving from a box software company where we'd have really huge releases every couple of years, we wanted to go to a way more agile and much higher velocity development model. We built a tool called Moonbeam, which is an opinionated Git-based workflow that relies on branching. We also enforce 12-factor design principles, one of which is that everything should be stateless. Okay, so we really said, all right, you want to use this platform? These are the rules of the road. The third one is clusterization. That's really where my team comes in. We run the underlying infrastructure and platform itself. And what we wanted to do was we wanted service teams to be able to use the platform in a self-service manner, a la AWS. So how you use the platform is you upload a spec file which describes your service, right? What repo you are in, what are your scaling parameters, what AWS regions you want to be hosted in, and you hit go, and you don't have to talk to a human, and you literally get an environment, okay? So what else do they get out of this type of engagement, okay? Compliance and security, so that all falls into our bucket. We know that developers really love to do compliance and security, okay? Automated efficiency reports, because it's a centralized platform, we can have that insight to figure out, wow, your workload's way overscaled. Monitoring and log aggregation. HA with the enforcement of placement constraints, and drum roll, please, the use of Spot. We can actually use Spot under the covers and without having to expose that type of design to developers. So we talked about reclamation. Reclamation is it happens, and I'll talk a little bit about kind of what we've seen ourselves in terms of what the reclamation process is like. It's not bad. You can easily deal with it, and I'll describe how. Okay, so we wrote a custom component on our platform that we call Booster, and what that does is it listens to a termination or a reclamation event emitted via the AWS instance metadata. Right, that's when the 2-minute clock starts, right? Where we just kind of, all right, guys, time to pick up and leave. We then do what we call an express drain on the node. So we give all the containers on the node 2 minutes to finish up their work, and then the instance goes poof, right? And then what we do in order to maintain demand or maintain balance within the cluster is that we provision a corresponding on-demand instance. And we essentially get HA because we enforce placement constraints. So one of the questions in our last session I got is, well, how do you go back to using Spot, or kind of what is your fleet composition? We actually within the platform itself we can define the percentage of Spot versus on demand. So in our lower level non-production environments, we kind of really don't care that much because they're not publicly exposed. So we can go, say it's 100% Spot, right? It's all right, we can take an outage for a couple minutes or wait for additional capacity. And then, just to keep like the math simple, say we had, 100 node cluster, 50% on Spot, 50% on demand. So we'll provision on demand, and then when we have to scale out, we'll always pick Spot first. Unless it's up to, say, our 50% watermark. Okay, reclamations they happen per AZ, and they happen in kind of bursts, and then it's pretty much quiet. It's not like a huge wide-scale event, and so as long as you enforce placement constraints across AZs, it shouldn't be a problem. We've been able to really orchestrate our way kind of around it. We also use fleet diversification. We use different instance types, so if we can't get an instance, get the next one, and then the next one, and so on. And then specifically 2 Amazon regions for Adobe, we've seen really decent cost savings. All right, so what's next? So we bet on the wrong horse, I'm happy to tell you, and we bet on Mesos a couple years ago. So right now we're in the process of getting off our Mesos-based scheduler and going to Kubernetes. We're doing that in a no downtime fashion. Serverless and functions are a really interesting use case. Remember, we're kind of platform agnostic. We're still in our data centers. We're also in public cloud, i.e. AWS. And so, how can we create like a serverless and expose that on our platform? We're looking at Apache OpenWhisk. And being a platform, I need to really drive adoption within Adobe, right? Developers, we want to expose all these great features to them, and maybe they're not doing these types of design principles that I mentioned. So, we want to drive adoption, and so we also want to find use cases. We want to have conversations with teams to find out, do we need to implement a feature request, kind of, find out what those fits are. All right, I'll turn it back to Chad, who's got a special parting gift to tell you.
Yeah, thank you, John. Great job, thanks. So first of all, I just want to say thank you for spending the morning with us. Appreciate your time. Thank you to our speakers, to John and to Devang for hanging out with us and telling us how they're using Spot in production in their environments. I want to head back to our contact information so you can reach out to me if you have any questions. Sorry, I'm just going to do this real quick. Reach out to me if you have any questions that you'd like to learn more about Spot. Find me on Twitter, find me on LinkedIn, or shoot me an email. There's my name. So I couldn't put my email address up here for some reason. But reach out to me. I'm more than happy to interface with you, get you connected. We have $50 in Spot credits for everybody. So meet us at the back of the room on your way out, grab some credits, and hang out and ask questions if you have any. I'd love to have you on the stage with me next year talking about how you're using Spot in your environment. And have a wonderful time at reInvent. Please don't forget to fill out the feedback forms. We really appreciate your feedback. And again, thank you so much.